So I study the neurobiology of decision making, how brains make decisions. And one of my main interests is in trying to translate the folk psychological concepts like confidence into objects that we can study scientifically at the level of the brain and neural circuits. So let me tell you first a story. So imagine someone tells you about a new restaurant, and you get the instructions and you start driving, and you see the sign that tells you this is where you have to turn, and you take the turn, and you keep driving, and there's no restaurant. And you keep driving, no restaurant. At some point, you're going to turn around. When do you turn around? If you know your degree of confidence, it's kind of when your confidence level bottoms out is when you would take that U-turn. And this is the kind of question that we try to translate into neuroscience. So, of course, these kind of questions have been of interest to a wide range of fields, from economics to psychology, from medicine to computer science. But what's unique about what we can do in neurobiology is really try to understand the mechanisms at the level of individual neurons, the nerve cells of the brain that are sort of the workhorses of the brain, and understand how their connections, how the architecture and how the dynamics that runs on that architecture allows us, or allows mammals in general, to make decisions, to compute confidence about decisions, and so on. So there are many reasons to use rats. So first of all, I should say that from an evolutionary perspective, rats are not that different from us, and some of the fundamental brain architecture is really common, and that really allows us to tap into a system that's simpler, and that's a great advantage. And in that sense, I think one of the perhaps underappreciated aspects of studying a simpler system is, imagine if you wanted to understand how a car works. You might want to start with the latest Lexus, but then perhaps you get lost in all the latest gadgets, the stereo, the GPS, the air conditioning system, the motorized car seats, and you forget about the fundamentals. Perhaps it would be better to start with the Ford Model T. It's a very simple car, but has all the components that makes it a car. In some ways, we feel that rodents have all the components that make them function, that make them able to decide, and it's going to be easier for us to understand. And of course, by using rodents, we can also tap into an enormous field of technologies that really allow us to get mechanistic, not just observe in general what a brain region is doing, but observe at the level of individual neurons. And finally, to actually understand how different neurons come together in circuits, and then manipulate these, and really understand the causal substrate of decisions. And that's really one of the things we're excited about, that we can do this now. So what we do is train rats to make simple two alternative choices between a left and a right port. And you can see in the center, the animal gets an odor, and then we train them so that they respond to the left reward port for odor A and the right reward port for odor B. And as you can see, they can do this really fast. We can get hundreds and hundreds of trials. They're really good at it. And in fact, one of the problems that we faced was that they're so good at it that they almost don't ever make mistakes with any two odors. So what we do to make them uncertain is to mix the two odors. And then we ask them to decide whether a particular mixture is more like mixture A, or more like odor A, or more like odor B. And that's the fundamental task that we study. So now we can translate our story about going to this restaurant and trying to turn around into a rat task. So imagine the same scenario where the animal is going back and forth between a stimulus and a response, but we delay the reward. It's a little bit like the restaurant that may or may not appear on the road. and we can ask how long is an animal willing to wait for the reward. Then what we can do is we can make the stimulus more difficult. We can dial in the difficulty based on the mixture ratio, and it's a little bit like changing your memory of the instructions of how to get to the restaurant, or changing how foggy the day is, and how well you can see the sign. So we can vary those things, and then measure how long an animal is willing to wait for the reward, and again do this hundreds and hundreds of times a day, which really allows them, first of all, to calibrate their confidence in these simple decisions, and then also allows us, from a neurobiological perspective, to actually look into the brain and what happens in their brains when they're doing this task. So we were faced with that when studying confidence. And what really happened is that we made an observation by recording the activity of neurons in a particular brain area called orbitofrontal cortex. We were struck by the pattern of activity that was really surprising to us. And this activity actually occurred while the animal was waiting for the reward, after he made his choice, but before he got any feedback. So he was uncertain, he was anticipating the reward. And in this period, we found that the activity actually could predict how likely that he was going to be rewarded. And we had a hunch that this is confidence. So then, as we sort of wanted to really confirm this and understand it better, what we did was to construct a computational model. And we realized that from a statistical perspective, computing confidence is really a fundamental operation. So we constructed a very simple model that did just that, compute decision confidence. And it turned out it explained all of our data. And now we reduced the question of confidence to a smaller question about decision confidence, to a question about a model. And now we can ask the questions: is this model unique? Is it general? Are there other alternative explanations? And so on. But these are all scientific questions that we can address iteratively. So we managed to really reduce this folk psychological concept of confidence to a smaller problem that we can get a handle on.